circuit. Okay, you can see here a current I is coming like this. Okay, now when it is coming to this node, it is getting divided into I1, I2 and I3. Okay, so this is I1, this is your I2 and this is your I3. Okay, so you can see that they all will converge at this point now. Okay, so they all are incoming here. So there will be an outgoing also. Can you tell me what is this outgoing current? What should I write in place of this value?
18.
No, right now I am saying as per this circuit diagram. What should I write here?
I1 plus I2 plus I3.
Very
I.
good. Just. Okay, so this is nothing but I1 plus I2 plus I3. So that
Yes, sir.
total amount of current is coming here. Can you
Yes,
tell
sir.
me what this I1 plus I2 plus I3 equals to?
I.
How? Because this is incoming and these are outgoing. So this is
Yes,
equal
sir.
to I.
Outgoing.
Okay.
I.
So you can see here I is coming and after parallel branch again I is coming. Okay. So
Yes, sir.
same current is passing through 2 ohm and this 2 ohm resistor. Okay.
Yes, sir.
You can verify this.
Mm.
So when we are talking about these two concepts, here we are talking about incoming and outgoing current. Okay.
Yes, sir.
So when we are talking about incoming and outgoing current, actually we are talking about Kirchhoff's current law.
Current law.
Okay. So here we are concentrating on the KVL part.
This is.
Now suppose this is a circuit diagram. Okay. You just remember the values 2, 2 and 12, 20, 30. Okay.
Yes, sir.
So okay. So 2, 12, 20, 30.
Yes, sir.
Okay.
Mm.
This is 2 ohms and this arrangement is connected again to
2
2
ohms.
ohms. This entire arrangement is connected to a battery of how much?
100 volt.
100 volt.
100.
Okay.
Yes, sir.
Okay. And it shows it is showing like this is I.
Yes,
Okay.
sir.
So you can see at this circuit. Okay. So what is this, students? These three resistors. What can I say about them?
Parallel.
Connected
Okay.
parallelly.
Okay. So we'll try to calculate R equivalent first.
Yes, sir.
Okay. Which is equivalent circuit of this. So this is R1, R2, R3. Its value should be R1, R2, R3,
R3.
R1, R2
R2 plus
plus
R2.
R2, R3 plus R3, R1.
R1.
Okay, so when I put the values 12 into 20 into 30, 12
25
into
by 6.
20 plus 20 into 30 plus 30 into 12. Okay, so
25
this
by
is again 20 into 30. So this is 240, this is 600, and this is 360. So these two will 600 and this is 600. So 1200. Okay. So I'm having 12 into 20 into 30 by 1200. Cancel. 12, 12 cancel. So 6. Are you getting R equivalent as 6 ohms, students? Please cross verify.
Yes, sir.
Okay.
Yes,
So
sir.
this circuit now, what circuit you have is like this. Okay. I current was coming like this and it was this. This is 2. This is 2. And this is 6.
Yes, sir.
Okay. Connected to a battery
Yes, sir.
of 100 volt. So what
Yes.
can you say about these three resistances now?
They are in
Connected
Parallel.
series.
Sorry, sir. Series.
Because only one path of
Yes, sir.
current and end-to-end connection of resistances. So R equivalent dash, now I'm trying to find, it is nothing but 2
10 volts.
plus 6
10.
plus 2. So this is 10 ohms.
Yes, sir.
So this is overall equivalent circuit of overall equivalent resistance of this circuit. Okay, and voltage overall is given as 100
100.
volt. So V is equal to IR. So I will be V by R will be equal to 100 by 10. So I total is 10 amps.
10.
So I know that amount of 10 amperes is coming, going like this at this node and coming out of this node. Okay. And now it is divided into I1, I2 and I3 here.
Mm.
Is it fine, students?
Yes, sir.
Till now? So what we did, we simplified this circuit and find out the current passing through this circuit, total current. Okay. So my intention here is to calculate I1, I2 and I3. Okay. Now you consider this part. What can you say about the voltage across these three elements?
Sir, equal.
Why?
Sir, parallel.
Because they are connected in parallel, since one end of each resistor is connected to one common point and another end is connected to second common point. So this is nothing but a parallel arrangement. Okay, so these all signifies the equipotential part, these 2 points. Okay, so this is same voltage. So I can say that V across 12 ohms is equal to V across 20 ohms is equal to V across 12, 20 and 30, right? 30 ohms. So this is equal. Why? Because since 12, 20 and 30 ohms are connected in parallel.
Parallel.
Okay. So voltage is always equal in parallel. So this is I1 multiplied by 12 is equal to I2 multiplied by 20 is equal to I3 multiplied by 30. Okay, so I have a relation like this, and I have one more relation, that is I1 plus I2 plus I3 is nothing but I. So this value of I have calculated as 10 amps. So I have one more equation as 10 equal to I1 plus I2 plus I3. Okay, so how can I write I2 in terms of I1 from this?
I2 in terms of
I2 is I1 into 12 by 20,
20.
6
Yes,
by
sir.
10 or 3 by 6 by or 3 by 5. Okay, so 3 by 5 I1. Okay, so this is I2. How can I write I3 in terms of I1? So these two I'll use.
By
So
30, sir.
I1, I3 is
I1 into
uh,
12 by
4
30.
by 4 by 10 or 2 by 5. Okay, so 2 by 5 I1. Is it clear or correct, students?
Yes, sir.
Okay. Now I'll put these two values 1 and 2 in this equation. Okay, so 10 equal to I1 plus 3 by 5 I1 plus 2 by 5 I1.
Mm.
Okay, so 5 is LCM, 5 I1 plus 3 I1 plus 2 I1 is equals to 10. So this is 10 I1. Okay, so 50 is equal to 10 I1, which will give us I1 equal to 5 amps.
5.
Okay, so if I1 is 5, I2 is 3 by 5 into 5, which gives me 3 amps. Okay, and I have I3 also. So I3 is 2 by 5 into I1 is 5. So this is 2 amps.
2 amps. Yes, sir.
Okay, so what I get? I1 5,
5,
I2 3,
3,
and I3 2
2, sir.
amps. So now if you go to this circuit, this is 10. Okay, this is
Yes, sir.
5, this is 3, and this is 2.
2.
So you can see here your 10 is equal to summation of these. So you have to find I1, I2, I3 like this.
Mm.
Is it clear, students?
Yes, sir.
Yes,
Okay,
sir.
so I got students ask. Okay, so but I am getting in 5, 3 and 2. You guys are getting in 0.8.33, 3.33. Okay, please cross verify your answer, students. Anyone who is getting the exact same answer? Okay, so you have to cross verify this. Okay. So
Okay,
I'm
sir.
ending the session now. I've told you I have a class now. So we'll start from the next problem, a complicated problem, and try to apply KVL in next class. Okay. So please start preparing and start solving from your book or the study material that I have provided. Anyone having any doubt or wants to say something? Anyone? Okay. Thank you, all of you.
Thank you,
Thank
sir.
you, sir.
Have a nice day. Yeah, sure.
Thank you. Sir,
Yeah.
the equalization of 12, 20, and 30, sir, I solved it by 1 by R method. So, but I am getting different answer.
How much?
20 by 3.
6.66.
Yes, sir.
No, it should come direct. It should be like values are given in such a way that you should get a direct number.
Yes, sir. I'll check again.
Yeah, you just check. Okay. Okay. Thank you.